So you're using Kubernetes and perhaps you're wanting to get into GitOps, which is storing your YAML manifests in a Git repo and then having your pipelines automatically synchronize from the Git repo. In theory, this is a great concept, but the first question that comes to mind is how do we store everything in Git? Things like secrets. Now the general recommendation is to store secrets in something like a vault and manage it outside of Git. But what if I told you that there's another way? GitOps is the process of having your infrastructure declarations in Git and having pipelines synchronize those declarations to the actual infrastructure. We cannot put secrets in Git, but this is where sealed secrets come in. A sealed secret is a secret that is strongly encrypted and can be made public, just like public SSL traffic. We store that in Git, so when our GitOps pipelines run, it deploys the sealed secret, and your cluster would know how to decrypt the sealed secret and converts it to a general secret. This means your application pods in Kubernetes still references the actual secrets and has no knowledge of what's going on. The only thing that really changes is us operators will interface with a sealed secret instead of the actual secret. So instead of us deploying Kubernetes secrets, we will take our secret object and convert it into a sealed secret and deploy that instead, which means we can then actually commit these sealed secrets to a Git repo and fulfill our GitOps dream. In today's video, we're going to be taking a look at sealed secrets. We have got a lot to learn, so without further ado, let's go. Now, if you take a look at my GitHub repo, I have a Kubernetes folder, and in the Kubernetes folder, I have what's called a secrets folder, and in here is a secret.yaml. This references my basic guides to secrets. Now, in this video, we'll take a look at the subfolder called sealed secrets, and in here, I have a README file. This is our introduction to sealed secrets. We're going to be taking a look at the sealed secrets documentation. We're going to create a Kubernetes cluster, take a look at the installation guide, the features, and take it for a spin. So be sure to check out the link down below to the source code so you can follow along. So there are a few use cases for using sealed secrets. The first one is for GitOps, storing YAML manifests in Git and then using GitOps tools to sync those manifests to your cluster, something like Flux or Argo CD. You might already have a process for managing secrets outside of GitOps, but sealed secrets makes it possible to include secrets in your GitOps pipeline. The other use case is giving teams access to secrets without revealing the secret material. So you can give them access to the sealed secret so they can see the encrypted value. So if they're comparing what's in Git to the actual secret, they can compare the encrypted value. So they know that the secret has been deployed, but they may not know the actual value. So the developer may ask, I want to confirm my deployed secret value is X in the cluster. So the developer can compare the sealed secret YAML in Git with the sealed secret value in the cluster and confirm they're the same. That's another use case. Now the first thing we're going to need is a Kubernetes cluster, and for that I'd like to use a utility called Kind, which is a lightweight Kubernetes cluster that runs in a local Docker container. And the beauty about Kind is I can run multiple Kubernetes clusters side by side. It's very lightweight, so I can spin them up and down within a few seconds. If I make a mistake, I can simply delete the cluster and start again. So to create a Kubernetes cluster, I use a utility called Kind. I say Kind create cluster. I'm going to call my cluster sealed secrets, and I'm going to run Kubernetes 1.23.5. I copy this, paste it to the terminal, and this will go ahead and spin up a lightweight Kubernetes cluster in a local Docker container that I can use for testing. And a couple seconds later, we can now see our cluster is ready to go. I can confirm this by saying kubectl get nodes, and we can see our cluster is now up and running. We have one node in our Kubernetes cluster. So the first thing I'm going to do is run a lightweight Alpine container. And the reason I'm going to do this is because I need to install a few utilities like Helm and kubectl. It also gives me a small portable Linux sandbox, so when you're running the demo in your spare time, you'll know the outcome will be the same. So if you already have all the Linux utilities locally, you can go ahead and skip this step. But I'm going to run a lightweight container by saying docker run -it, and I'm going to mount my home directory into the container so I have access to my kube config. I'm also going to mount the local working directory into the container, so all the source code we have in here, and then I'm going to run Alpine and give it a shell terminal. Go ahead and run that, and now I'm in an Alpine container. I can do ls, and we can see we have all the files that are on the left here in the container. And then what I'm going to do is go ahead and install kubectl. So that's very easy. I'm going to get curl, because I'm going to need curl to download the latest kubectl version, and then I'm going to use curl to download kubectl. I'm going to give it chmod execute permissions, and I'm going to move it to user local bin, which is the path so that we can run the utility. I'm going to go ahead and paste that to the terminal, and that'll download kubectl. And now I should have kubectl running inside of this container. You can see I have access to it. We can also run kubectl get nodes, and we can see we have access to our cluster. And the next utility I'm going to need is Helm, because I want to use the Helm CLI to access the sealed secrets Helm chart. So to get Helm, I use the same method as kubectl. I run curl. I'm going to go ahead and get the tar file for the latest version of Helm. I'm going to untar it, so basically extract it to a temp folder, and then I'm going to move that Helm binary into user local bin so that I have access to it, and I'm going to give it execute permission. Go ahead and copy paste that to the terminal, and that'll go ahead and install Helm. And now you can see I have Helm installed by saying Helm, and we get a response. So the Helm CLI and kubectl is now installed and ready to go. So now that we have our cluster, the first thing we're going to do is get the sealed secret manifests. Now you can go and download the YAML file, or you can use the Helm chart. So if you want to download the YAML or just take a look at what the latest version is, we're going to be using version 0.19.1 on the GitHub releases page. So if you follow that link, you'll end up on the sealed secrets GitHub repo on the releases page. And if we scroll down, we can see here is the controller.yaml. So this is the file you'll need to deploy the sealed secrets controller. So what I'm going to do to download this is I'm just going to use curl. I'm going to say curl, and I'm going to download it into a local folder under Kubernetes secrets, sealed secrets, and this is the controller 0.19.1.yaml, and then here's the URL where I'm going to get it from. So that is the link from the GitHub releases page. Go ahead and copy paste that to the terminal, and that'll download the YAML file. If we take a look at the YAML file down on the left, we can see we have controller.yaml. It's a simple deployment. It's called the sealed secrets controller, one replica. If we scroll down, it has all the basic deployment stuff. It also has a custom resource definition because we're going to be dealing with sealed secret objects, and it has a service account and role binding so that it can read stuff. And to install it, it's pretty straightforward. We simply apply that YAML. The alternative way is to install it using Helm. So to do that, you can add the Helm repo by saying Helm repo add sealed secrets and the URL to that repo. Go and paste that to the terminal, and you can see we've added the repo. Then we can go ahead and do Helm search to search the latest version. If we paste that to the terminal and we scroll up, we can see the latest version is 0.19.1. This is the application version. Remember that the Helm chart version is different from the application version. So if you want to use the same version as I'm using in this demo, you'll get chart version 2.7.0. Now you can do Helm install, or you can simply do Helm template to take a look at the YAML by running Helm template sealed secrets, the version which is 2.7.0. It uses by default the kube system namespace and then the chart name, and what you do is you pipe the output to a YAML file. If you want to take a look at the YAML, if you run this, you'll see this will generate all the YAML as well. We've got all the YAML over there, or you can just use Helm install instead of the Helm template command. In this demo, I'm just going to install it using the manifest. So I'm going to say kubectl apply, and I'm going to apply the controller manifests that I've downloaded off the GitHub releases page. Copy paste that to the terminal, and that has gone and deployed the controller. Now, depending on where you installed it, you want to go and check the installation. Now, the default location is in the kube system namespace. So I'm going to do kubectl in the kube system namespace get pods. Go ahead and run that, you can see now here we have the sealed secrets controller. And also what we want to do is go ahead and check the logs of the sealed secret controller. So we do logs, and we can just get the logs by label and say tail -1, so we can get all the logs. And the important thing we want to notice here from the log output is we can see that it prints out the version, it's starting it up, and it automatically creates a new encryption key, and it stores that in the kubesystem namespace. And here's the name of the encryption key. So this controller, when we encrypt secrets and create sealed secrets, it's going to be using this secret value here as the encryption key. We'll take a look at these encryption keys in a bit. Now, before we dive further into sealed secrets, just a quick word from our sponsor who made this video possible. When you hear the word Kubernetes, you most likely think of YAML files. And when you think of YAML files, you think hundreds of files, thousands of lines, and two things come to mind here: human error and misconfiguration. Now, thankfully, there is a free and magical open source utility that helps us solve these challenges, and it's called Tree. Tree is a tiny command line app that helps us test our YAML files. It checks our YAML for broken YAML syntax, for valid Kubernetes schema, and also helps enforce and checks policies, and also helps manage these policies from a dashboard. You can even run Tree in your GitHub action pipeline and prevent your precious pipeline from running if any YAML misconfiguration or policy issues are detected, as the tree supports multiple CI/CD workflows. The tree also ships in the form of a Kubernetes webhook, which can run the tree every time resources are applied to your cluster. This means the tree can run at every stage of our software delivery workflow. It can run checks locally, in our CI pipeline, during deployments, and also run against resources that are already deployed, end to end. The tree also supports Helm, has native customized support, lots of official integrations, as well as community plugins like VS Code. Now, this video is proudly sponsored by Tree. Check out the link down below to my full Tree tutorial. Now, it's pretty important to understand the encryption process. The controller will generate a new encryption key the first time it starts up, and it'll keep this encryption key in a Kubernetes secret. It'll also generate a new key every 30 days. So the latest key remains the active one, which is used to seal new secrets and create sealed secrets. The old ones are kept there just in case an old sealed secret needs to be decrypted. If you lose these encryption keys, you may not be able to retrieve your secrets from the sealed secret. So the latest one is always the active one, but the old ones are important to decrypt old sealed secrets. If you want to get rid of the old encryption keys, you have to re-encrypt all your secrets to create new sealed secrets. Now, to take a look at the encryption keys, we basically want to get the secrets out of the namespace where the controller has been installed. In this case, it's the kubesystem namespace. So I say get secrets, and we can see we have a sealed secret key with some random string behind it. So this is our encryption key that was generated by the controller when it started up. We can take a look at that key by extracting the YAML file by saying kubectl get secret, the name of the secret, and output it as YAML. If we do that, we can see that this is a TLS based secret. You have a public certificate and you have tls.key. So it's using this as the encryption and decryption key. Now, if you lose this secret value, you will not be able to decrypt your sealed secrets, and you will need to go ahead and take all of your secrets and reseal them with a new key. Now, there is a process of backing up these encryption keys, but you have to keep them safe. You can restore them to the same cluster or migrate them to a new Kubernetes cluster if you want to migrate clusters. You also have the flexibility to configure rotation, and it's possible to turn it off. Now, to create our first sealed secret, we have to use a new utility called KubeSeal. KubeSeal is a command line utility that takes a Kubernetes secret, it passes it to the cluster, the sealed secret controller will take that secret, use the encryption key to encrypt it, and create what's called a sealed secret, and then it will return you the sealed secret value. Now, getting KubeSeal is very easy. It's the same method as getting the controller controller YAML. So you go to the GitHub releases page and you scroll down, and right where we got the controller YAML earlier, if you look down, there's a bunch of binaries and tar files for the KubeSeal utility. So I've made the install pretty straightforward by following the same process using curl. So what I'm going to do is say curl, I'm going to download from the GitHub releases page version 0.19.1. I'm going to grab the KubeSeal Linux AMD 64 tar file. I'm going to untar it to my temp folder, and I'm going to give KubeSeal execution rights and move it to user local bin. Copy paste that to the terminal, and that will go ahead and install the KubeSeal CLI. Now that that's installed, we can go ahead and test it by saying kubeseal --help, and we should see that the utility is now installed. Now we can go ahead and seal our first Kubernetes secret. So if you're familiar with secrets, if you take a look at my GitHub repo, I have a Kubernetes folder and a secrets folder, and in here I have a secret.yaml. And we can take a look at that secret YAML by running cat. I'm just gonna say cat Kubernetes secret sealed secret.yaml, and this is what that secret looks like. This should look familiar to you. I have a basic Kubernetes secret. It has a secret JSON in here with an API key with some secret value. Normally I would go ahead and apply the secret to my cluster, and I'd have to keep this YAML safe. Or I would use something like a vault and inject the secret at runtime. Now there are multiple ways of generating a sealed secret using KubeSeal. If I run KubeSeal, you will see that it basically waits for standard input. So what I can do then is go to my YAML, select all, say Control-C to copy it. I can go to the standard input, I can paste the YAML, and I can press Control-D to terminate standard in. Now what it's done when I press Control-D is it passed the YAML to KubeSeal. KubeSeal has gone off to the cluster, asked the sealed secrets controller to encrypt the file, and it spits back a sealed secret JSON file. Have a look at this. This is a new object called kind sealed secret, and it has a normal spec template, metadata, and a name. Its name is called my secret, and it has this field called encrypted data. So it has our secret.json here, and you can see the value is now encrypted. This is one way of doing it using standard in. Now there are two ways to automate this. We can automate using standard in by saying cat the secret.yaml, pipe it to KubeSeal, and we can tell KubeSeal to output YAML and then output this file to a new file under Kubernetes secrets, sealed secrets, and we're going to output it as sealed secret.yaml. This is one way of doing it, which kind of automates what we've just done. So if I click that, and we go down here to our Kubernetes secrets, sealed secrets folder, you see a new sealed secret.yaml. And if I look at that, this is what the YAML looks like. So it's kind sealed secret. It has a name called my secret. It would go into the default namespace, and it has the encrypted data. This is one way using standard in. I think a preferred method is to just directly call KubeSeal. So here I just say KubeSeal -f, and I pass in the path of my secret.yaml, and I say I want to output YAML, and then I pipe the output to the sealed secret.yaml. So this is probably a preferred way so that you don't use cat and you don't use standard in. Go ahead and paste that, and that'll override the file. If we take a look at that, it would just re-encrypt it. So that is two ways of creating a sealed secret. We now have the sealed secret.yaml, which we can now give to our developer, and we can go ahead and deploy that using something like GitOps. And we deploy it just like we deploy a regular secret. We say kubectl apply -f, and we just deploy the sealed secret. Now before I do that, if I do kubectl get secrets, notice that there is no secret yet in this namespace. But if I go ahead and apply, and I say apply my sealed secret file, and then I do kubectl get secrets, notice that my secret value is now here. So me as a developer has gone ahead and applied the sealed secret, so I have access to the encrypted value, and the controller has gone ahead and decrypted that sealed secret and created a general Kubernetes secret. So now I can go ahead and use the sealed secret in my GitOps pipeline. Now when we run KubeSeal, we pass the secret.yaml. KubeSeal will pass that to the cluster, and the sealed secrets controller will use that encryption key that we saw earlier to encrypt the file. And I mentioned earlier that we can configure the key rotation. Now to set the renewal period for a new encryption key, we simply set this command line flag on the sealed secrets controller called --key renew period. Its default is 30 days. So to test this, I can set it to a value like 5 minutes so we can see what it looks like. So what I'm going to do is I'm going to install a lightweight text editor called Nano in my container. I'm going to export the cube editor environment variable so that I can run kubectl edit, or you can just edit your controller YAML directly. What I'm going to do is I'm going to say kubectl edit. I'm going to edit the deployment, the sealed secrets controller in the kube system namespace. If I go ahead and run that, that'll bring up Nano and we can go ahead and edit this. And what I want to look for is the spec where the actual container is, and there's a command here you can see, and under controller we basically want to extend that, so we want to say dash and pass in our key renew period to 5 minutes. So I'm going to go ahead and paste that like so. Go ahead and run that, and that will restart our sealed secrets controller. And now we can already see there's a second key being created. And if we give it 5 minutes, we'll see a third key will be created. Now, I believe if you set this value to 0, you actually turn off rotation. So that'll give you an idea of what it looks like over time when new encryption keys become active and old ones are kept in case they are needed. Now, it is important to keep all the old encryption keys unless you are sure that they're no longer needed. If you regularly re-encrypt all your secrets and create or replace your existing sealed secrets by re-encrypting them, you can safely get rid of the old keys. Now, to create a backup of our encryption keys, we simply extract them just like we do with a regular Kubernetes secret. Now, to back up our encryption keys, it's as simple as grabbing all the Kubernetes secrets by a label. So all we're going to do is say kubectl get secret in the kube system namespace and get them by label by saying -l, and this is the label you need, with the value being sealed secrets key. And we want to output that as YAML, and we can just pipe it to a file here locally and see what it looks like. So I'm going to go ahead and paste that to the terminal, and that will give us our sealed secrets key in the bottom here. I'll take a look what that looks like, and you can see that this is just a list of secrets. Now let's say you want to go ahead and restore your encryption keys to the same cluster, or you want to migrate all your workloads to a new cluster. So what I'm going to do is I'm going to go ahead and delete my cluster, spin up a new one, and then watch the sealed secret controller deal with my sealed secrets. So let's try this by migrating our encryption keys to a new cluster. So what I'm going to do is I'm going to say kind delete cluster and go ahead and delete that Kubernetes cluster, and then say kind create cluster and basically just recreate it. Go ahead and paste that. That will create a new Kubernetes cluster. We can go ahead and check our cluster by running kubectl get nodes and see that it's up and running. We can then redeploy the sealed secrets controller because we've created a brand new cluster. So I'm going to go ahead and copy this and paste that to the terminal. That'll deploy the sealed secrets controller, and I can say get pods, and I can see the new sealed secret controller is creating. And if I wait a few seconds, we can now see it's up and running, ready to go. So what we want to do now is restore our encryption keys. So I'm going to say kubectl apply -f, and I'm going to apply that key file that we backed up earlier. Go ahead and run that. That'll apply, and you can see it's created the two keys we saw earlier. And now what I can do is I can go ahead and deploy my sealed secret. So on the left here we have our sealed secret. This is our encrypted secret that we want to deploy. So to deploy that, it's very simple. I say kubectl apply -f, and I apply the sealed secret.yaml file. Go ahead and paste that, and look what happens now. We've created the sealed secret called my secret. Now, interestingly, if I say kubectl get secrets, notice that my secret is missing. It's not actually there. So how do I troubleshoot what went wrong? Just like you troubleshoot any resource in Kubernetes, you use the describe command. So what we do is we say kubectl get sealed secrets. We can see the sealed secret is there. And then what I'm going to do is I'm going to say kubectl describe sealed secrets with the name of my secret. And I can see there's an error unsealing it. Failed to unseal. No key could decrypt the secret. Now, why is that? Now, the sealed secret controller cannot read and cannot decrypt our sealed secret because it doesn't have the encryption key. It only reads all of these encryption keys when it starts up. Now, because we deployed the sealed secret controller, it was already running when we restored our encryption keys. So this is just a little gotcha you have to know, that you need to make sure all your encryption keys are there before starting up the sealed secret controller. So the encryption keys are only read when the controller starts. So it's very simple. All we need to do in this case is delete the pod. So we delete the pod of the sealed secret controller and basically just let it restart. Now when we do that, we'll see a new sealed secret controller pod will start. And now if we do kubectl get secrets, we can see our secrets been decrypted. Now there may be many cases where you'll want to re-encrypt your sealed secrets. Let's say you may believe that your encryption key was compromised, or people who have access to those encryption keys have left your organization, or you simply want to build a better security posture and a process of re-encrypting your secrets every now and again. Now KubeSeal has a re-encrypt command which takes a sealed secret, passes it to the controller and asks the controller to re-encrypt it with the latest key. One thing to remember is that KubeSeal and sealed secrets do not replace general password rotation. If you have sensitive information like a database password, you should be rotating those regularly regardless. Sealed secrets have nothing to do with this. For example, if your database password gets compromised and you go ahead and reseal your sealed secret, it's going to do nothing because the attacker already has your database password. So you need to be rotating passwords regardless. To re-encrypt a sealed secret, it's very simple. We just say KubeSeal re-encrypt. And the benefit of this is this will go ahead and re-encrypt the secret without having to pull and pass around the actual secret. So what I do here is I just say I cat the sealed secret.yaml that I already have, so the encrypted value, pipe it to KubeSeal -- re-encrypt and output that as YAML, and that will spit out a brand new sealed secret. If I do that, you can see it spits that out, so I can go ahead and use this one now. So what I can do is I can say I can run that same command, but I can pipe the output to a temp YAML and then replace my existing sealed secret. So if we take a look at my secret, this is the old one which has been encrypted. If I go ahead and run this command to re-encrypt it, we can see the value has changed. So we've re-encrypted our sealed secret without passing around or leaking the actual secret. So hopefully you've learned a new tool that you can add to your GitOps tool belt. If you liked the video, be sure to like and subscribe and hit the bell. You can also join the community with the link down below. And if you want to support the channel even further, be sure to click the Patreon link down below or hit the join button to become a YouTube member. And as always, thanks for watching, and until next time, peace.